Squares and square roots. A perfect square is a number that is obtained by multiplying by itself. A square root is the number that it's multiplied by itself to obtain the other number. Alright, for example, the square root of 49 is 7. 7 times 7, or 7 squared, is equal to 49. The number that is multiplied by itself is 7. Let's take a look at a perfect square. The side length is 1, 2, 3. Okay. Now I want to find the area. So to find the area of a perfect square, I'm going to take 3 times 3, or 3 squared, which is equal to 9 units squared. So the area is 9. Now, so when you think about this, if I give you in example 3, the area of a perfect square is 64. So if I give you the area, now I need to find the side length. Well, up here, you said 3 times 3 is 9. So right here, did you do 9 divided by 4 sides to get 3? No. What you have to do is take the square root. So the area is 64, so we're going to go ahead and find the square root of 64 is equal to 8. Therefore, the side length is equal to 8 units. Whenever given the area, you take the square root of the area and you find the side length. And let's check it. 8 times 8 is equal to 64. I want to go ahead and have you write this number line in your notes. These are all the squares and square roots that I would like for you to memorize. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So on the inverse, or the flip side, the square root of 9 is 3. The square root of 4 is 2. You can use your calculator, but it's kind of like your multiplication facts. I want you to memorize these. It'll help you in the long run. Let's practice. Alright, so we have the square root of 144 minus the square root of 36. So the square root of 144 is 12 minus the square root of 36, which is 6. So 12 minus 6 is 6. Let's do the next one. When they're right next to each other, that means multiply. So we have 15 times the square root of 16. We're always going to start with the square root first. So let's go ahead. We'll rewrite it. 15 times the square root of 16 is 4. 15 times 4 is equal to 60. There we go. The square root of 81 plus 20. First we're going to do the square root. The square root of 81, 9 times 9 is equal to 81. So the square root of 81 is 9 plus 20, which is equal to 29. Now we have a word problem. John's room is a square. Alright, so I'm going to draw John's room. John's room is a square with an area of 121 square feet. Alright, so it's 121 square feet. What is the perimeter of John's room? So the question is, what is the perimeter? So this is a trick question. Okay. So to find the perimeter, we're going to have to add up all the sides, or it's a square, so 4 times s. So first, to find the perimeter, we need the side length. I don't have it. All I have is the area. But we know, if you're given the area, how to find the side length. So we're going to take the square root of 121. I look up here. The square root of 121 is 11. 11 times 11 is 121. Okay? I know some of you wanted to divide by 4, but that is not how you do. You take the square root of 121 to get 11. Now we're going to find the perimeter. We're just going to say 11 times 4, because it's a perfect square. So 11 times 4, the perimeter is equal to 44. All right, let's now estimate non-perfect squares. Yes, you can use your calculator, but also you can use what you know. So if you have the square root of 45, let's go up here. The square root of 45. Well, it's between 6 and 7, the square root of 36 and the square root of 49. So we know it's somewhere in here. So the square root of 45. Now think about it. Is it closer to the square root of 49, or is it closer to the square root of 36? Is it closer to 7, or is it closer to 6? All right, so go ahead and pause the video if you need it. And the square root of 45, it's a non-perfect square, is approximately 6.7. Now I want you to find the estimate of the non-perfect squares of the square root of 18 and the square root of 2. Alright, the square root of 18 is approximately 4.2, rounding to the nearest 10, and the square root of 2 is approximately 1.4. So how'd you do? It's always a fun game. The last thing I want to think about is non-perfect squares. Are those rational or irrational numbers? They are irrational numbers.